So we're looking at this question, thermal processes worksheet, question 1. So what is happening here is there is a beaker of water and there is a fan which is blowing air. So basically it is creating a drought of wind. So what happens is the evaporation increases, and we know during evaporation the high energy particles leave the water, so the remaining water molecules have a low average kinetic energy, which means the temperature of them is decreasing. So that's why when you put the thermometer, the temperature decreases. So that's the A part. They're asking you to explain why the temperature of the surface begins to decrease. So in your answer you have to mention that the high energy particles are evaporating, and that means the average kinetic energy of the remaining molecules decreases, and that temperature depends on average kinetic energy. You have to mention all these 3 points. Then what he does is he puts the thermometer into the bottom and he observes that there the temperature begins to decrease. Now that will not be because of evaporation, because we know that evaporation happens only on the surface. But just as we learned about convection, here we have a cold air. So cold means the molecules will contract, vice versa to expansion. When you heat a fluid, it expands. So when you cool it, it contracts. That means this is heavier than this region, so it will fall and this region will rise. So this is kind of the reverse. We usually, when we think of convection, we think about heating it, and by heating the gas molecules we let them rise. But here we cool the top surface, but the same effect. So the name of the transfer, as asked in the question, is convection, and to explain it you have to explain that the surface water is cooling down, hence it contracts, and because of that it will sink down and the warm water from the bottom would rise. Just one difference here, this water itself was cooling down due to evaporation, but here the cool water is coming and the hot water is rising. So it is the thermometer, though the thermometer is kind of remaining in the same place, it is not surrounded by the same water.